Algebra students, I said in class today to a few of you, and I will say this a lot, there are easy ways to do these problems and hard ways to do these problems, and I don't care which way you do them as long as you get the right answer. I find it easier to simplify as much as possible before I raise anything to a power. So let's jump in here and take a look at some new rules that we're going to get. First, the zero power of exponents. Any base to the zero power is 1. And I'll try to explain it this way. What is 5 divided by 5? Well, we know that's 1. We also know that that's 5 to the 1 over 5 to the 1. So using the exponent rules that we learned the other day, it's 5 to the 1 minus 1, which is 5 to the 0. And it turns out if we know that any term divided by itself is 1, and we know that any term divided by itself would simplify to that term to the 0 power, then anything to the 0 power has to equal 1. That is true except for 0 over 0, because that would be 0 to the 1 minus 1 power, which is 0 to the 0. But many of you know, or you should know, you cannot divide by 0. So 0 to the 0 is undefined. That's an important idea. We are not talking about 0. Here we're saying A does not equal 0. Okay. Next rule we're going to talk about are negative rules of negative exponents. And I cannot stress enough. Look over here. A to a negative power, it's not a negative number. 1 divided by A to a negative power, it's not a negative number. A fraction to a negative power, it's not a negative number. A negative power puts what's in the numerator in the denominator as a positive power, or it puts what's in the denominator in the numerator as a positive power. I cannot stress enough that there are no negative numbers associated with negative powers. Now, granted, if it's negative 2 to the negative 1 power, well, then that's 1 over negative 2 to the first power, which is a negative number. But for the most part, we're going to talk about A being bigger than 0 and A not equaling 1 as we work in these exponent rules, because that's more interesting and more easy to deal with. But I cannot stress this enough. There's no negative numbers when you have a negative power necessarily. It depends on what the base is. So putting all these together, here are all the rules we've learned so far. When you multiply the same bases to different powers, you add the powers. When you divide them, you subtract. When you raise a power to a power, you multiply. When you raise a product to a power, the two individual factors get raised to the power. Same with a quotient. The individual dividends and divisors get the power. A to the 0 is 1. A to the negative m is 1 over A to the m. 1 over A to the negative m is A to the m. And then if you have a fraction raised to a negative power, the numerator and denominators flip and are raised to that power, positive power. So let's do some practice. I would suggest that you try this one on your own using those rules that you just wrote down. Write those rules down, try this problem. Write these rules down, try this problem. Write these rules down, try this problem. Okay, here we go. You've hopefully tried this problem. Here's how I would do this. 4 times 3 times x to the negative fifth times x to the third times y to the negative 3 times y to the negative 2 divided by 6 times x to the negative fifth times y to the third. Good? Lots of ways to do this now at this point. You do not have to do what I'm going to do. 6 goes into 3 with a 2 left over, so that 3 is now a 1, and there's no 3 down here. There's just a 2. 2 goes into 4 twice, so that is gone. It's just a 1. X to the negative fifth and x to the negative fifth are the same term, so I'm just going to cancel these out. That's all they do. I'm left with an x cubed in the numerator. Y to the negative 3 times y to the negative 2 would be y to the negative fifth in the numerator. Or I could take this y to the third, negative third, and draw it as, or write it as y to the third down here. I could take this y to the negative 2 and write it as y squared down here. Now in my next step, I just say, oh, it's 2 times 1 times x cubed times 1 divided by 1 times 1 times 1 times y to the third, y to the third, y to the second. That's y to the 3 plus 3 plus 2, which is y to the 8th. And I'm done. All right, we've got more practice for you, so try this one. Take a look at those exponent rules, write them down if you haven't already, and now try this one. Okay, this one's a little messier because we've got this parenthesis first, so I'm just going to say, okay, 3 to the negative 2, a to the negative 2, b to the negative 6. 3 times negative 2 is negative 6. Divided by 2, a to the negative 4th, b to the 0, which is just a 1, times a up here, times b to the negative 3rd. Next step, this 3 to the negative 2 jumps down here. This a to the negative 2 jumps down here. This a to the 4th comes up here. There's lots of ways to do it. The b to the negative 6 and b to the negative 3 I can add or then move down. So just how I would do this problem is I would start and I would say, okay, so first the 3 comes down here is the 3 squared. The 2 stays down here. This a to the negative 2 and a to the negative 4th. Negative 2 minus negative 4 is a squared. That means I get like an a squared up here. And I've got this other a right there. And then I've got this b to the negative 6th. So that's a b to the positive 6 in the denominator. And b to the negative 3 in the numerator becomes a b to the 3rd down here. Notice there's no negative numbers here. Now cleaning it up, a cubed, 2 times 9 is 18. I'd probably write that as an 18. If you want to leave it as 2 times 3 squared, I probably wouldn't take off points right now. B to the 6 times b to the 3rd, 6 plus 3 is 9. And there you go. Lots of ways to do it. I don't care if your steps match mine, but I do care if your answer matches mine. As long as you're getting the same answers, you're doing it right. All right, next problem. Real messy, but we just take it one step at a time. This is a problem where I'm going to simplify inside this big parenthesis before I worry about this. So I've got 3 times 6, x to the negative 2nd, x to the negative 6th, y to the 5th, y to the negative 2nd, z to the 3rd, z to the negative 3rd, divided by 9, notice the 9 is not being raised to this negative 3 power, x to the negative 6th, y to the positive 6th. Negative 2 times negative 3 is positive 6. This whole mess is going to be raised to the negative 3rd power once I simplify. Now, using a different color, 3 goes into 9 3 times. That 3 goes into 6 twice. X to the negative 6 cancels with x to the negative 6. Y to the 5th here, 5 of these go away with 5 of those, leaving 1 y there. Z to the 3rd times z to the negative 3, those would cancel out because that would be z to the 0. 3 plus negative 3 is 0. So those cancel each other out. So now inside that big parenthesis, I'm left with 2 times, oh, thank you so much, Java, so annoying. Stick with this here, it's all written over here, so let's just go ahead and I can't erase this, I'm sorry guys. Oh, that's frustrating. So 2 times x to the negative 2, that jumps down to the denominator as an x squared. Y to the negative 2 jumps down to the denominator as a y squared. Y squared times y is y cubed, and then the z's are gone. All of that is raised to the negative 3 power. So the final answer would be 2 cubed in the denominator, x to the 6th in the numerator, y to the 9th in the numerator. When the fraction is raised to a negative power, what's in the denominator moves up to the numerator, but it still has to get cubed. What's in the numerator has to move down to the denominator, but it still has to get cubed. The negative moves it from top to bottom or from bottom to top, and then don't forget to raise it to that power. All right, so there we go, guys. Thank you for following along despite the bad Java update request. Do your best. I would try this problem again, knowing that the answer you're looking for, if I write it down real quick, I believe was, what did we get? X to the 6th, y to the 9th, divided by 2 to the 3rd, or 8. See if you can get that answer. All right, guys, have a good night. Thanks for your hard work. Peace.